Has anyone heard of a function before? Know what a function is? Seen them, sort of? A function is simply this. Function is a rule that describes how two sets of numbers are related. A function is nothing more than just a rule that's going to describe how we go from one set of numbers to another. How are two sets of numbers linked together? And it's simply the rule that connects them. The two sets of numbers are these two words. The domain. Domain is all of the possible inputs to a function. Domain is any possible number you can plug in to a function. Inputs, domains. They're also called, they can also be called independent variables, which you'll see a lot in like science when we're graphing independent versus dependent variables.
Yeah.
They're also called independent variables. When you're graphing, say, an independent variable, what axis do we generally graph them on? Are they the x's or the y's? Are independent variables generally along the x-axis, or are they up and down the y-axis? Well, this is kind of scary. The domains are the inputs, and they're always graphed on the x-axis. Domains are very generally going to be the x's that we have for a function. Okay. The range is the other set of numbers that this function will connect to. So if the domain is connected to the inputs, what is the range going to be connected to? Outputs. So the range is all of the possible outputs to a function. All the possible outputs, I guess, of a function is probably better. Oh, shoot.
It's such a pretty circle.
It's too big. All the possible outputs of a function. And outputs, domain, inputs, x's, range, outputs, y's. Independent variables, domain. Dependent variables tend to be the range. Okay? I have some other words for those. Next. Knowing that, we're going to start to talk intelligently about functions and relations in particular. In our first example, it says the input-output table shows the amount of money that Miguel earns at his job for several number of hours. Identify the domain and range of the function. Okay? Well, this is not rocket science. What is domain connected to? All the possible inputs. Yeah. So if I ask you to list the domain or state the domain, then we'll state all the possible inputs. What are the possible inputs of this function?
1, 2, 2, 4, and 5. Just kidding, I'm looking at the wrong one. 2, 5, 7, and 8.
So the domain 2, 5, 7, and 8.
What did you do?
And the range of this function, therefore, should be what's left over. The range is 14, 35, 49, and 56. To tell whether it's a function, we'll make a mapping diagram. So what we're going to do is we're going to list, going down vertically, all of the possible inputs, or the domain, and we'll list the range going vertical next to it. And anytime we repeat a number, we'll just not write it down. We don't want to repeat any numbers that we see in the domain or range. So the domain of this relation is 1, 2, 2 again, so I'm not going to write it twice, I'll just write it once. 4 and 5. The range is the output, and the outputs are 0, 4, 3, 7, and 8. And I'm going to connect my domain to the range just the way they're connected in the table. So 1 gets paired with 0. 2 gets paired with 4. 2 also gets paired with 3. 4 gets paired with 7. 5 is paired with 8. Okay?
So in the next
before I want to interrupt you, Angela, in order to answer the question is this a function? Now all you need to do is look at this diagram and say, self, does every domain have exactly one output? Is every number in the domain paired with exactly one number in the range? No. What's the problem? 2 is paired with 2 different numbers. Since 2 is paired with 2 different numbers, because of this, this is not a function.
No.
This is just any old rainy day relationship. This is just pairing numbers together. This doesn't have a specific, every input goes to one output. Okay. Since every input has one output, this is, yes, a function.
Oh, cool.
Okay. I tell you the domain. We want to find the range. And the key point is that we have the rule. We have a rule, y is equal to x plus 4. So if you have a rule to go from the domain to the range, well, what number does 0 get mapped to?
4. 6.
2 gets mapped to 6.
11. 11.
Oh, you're going too fast.
Wow.
And 11.
Oh,
Use the rule, knowing that the domain is the x's, to plug in x into the rule, and it pops out what the range is. It pops out what your answer is.
What? Wait, say that again.
The domain is all the x's. And the function is the rule that takes you from x to y. So if I know what all the possible x's are, then I can plug each of those x's into my rule and get its partner y. 0 is mapped to 4. 2 is mapped to 6. 3 is mapped to 7, and so on. Okay? Is what's nice about a function, how domain functions and range are related. The function is that rule, that roadmap that takes you from the domain to the range. Okay.
That was magical.
What if we don't know the rule? I tell you the input and the output, we don't know the rule. Well, we can try to deduce the rule. So, do we see any pattern in the input versus the output? Is there a pattern between the input and the output? What pattern do we see?
Like the number can go up in order, like 1 to 2, you go up by 1, and then 2 to 4, you go up by 2, and 4 to 7, you go up by 2.
Okay, so we're seeing the way I wrote the input and the output, I'm going up by 1, up by 2, up by 3. Okay. When we're thinking of a rule for the function, what we're really looking at, the pattern that we really want to focus on less is how the x's change, and more, how is y related to x? Is there a pattern between how the range, or the output, is related to the input? Do we see a pattern forming between how the output is related to the input? If you have an input, what do you have to do to get its partner? One theory might be subtract 1. To subtract 1 whole. If I start at 1, do I get 0? What's 2 minus 1? 1. What's 4 minus 1? 3. What's 7 minus 1? 5. 6. So our rule seems to be whatever x is, I just need to take away 1 and I'll get my output.
Amazing.
As we move on through the year, we'll look at more and more strategies for finding rules. But in general, when you look for a function, we want to figure out a hard and fast rule for how does x relate to y. What do I need to do to x to get its part? And it should hold for every time. Or anything else, we want to come up with a rule that will relate how many lessons we go to how much money we spend. Does anyone have an idea of what that rule might be? To help us come up with a rule, let's make a table of possible values. So let's start with, well, how many different times might we go to a lesson? How many different lessons might we attend? What are the possibilities? Okay, we could go 5. So we might attend 5 lessons, but we could attend up to 5. So that doesn't mean we always have to go to 5. What other number of lessons could we go to?
12. 2.5.
4,
3.
Up to 5, so
3, 2, 1.
and we might just not go to any, right? So let's now relate how many lessons we go to how much money we'll spend. So if we go to 5 lessons, how much money will you spend?
$60.
How'd you know that?
Because I'm good.
5 times 12 is 60.
Because 5 times 12 is 60.
Oh.
How much money will you spend if you only go to 4 lessons?
48.
4 times the fee per lesson. So 4 times 12 is 48. 3 times 12 is 36. 24, 12. And if you don't go to any lessons, it should make sense that you don't spend any money. Okay. So now that we've got a table, and now we've thought about how to fill this table out, what was the rule that we were using? How is number of lessons related to the money spent? How is the amount of money you spend related to the number of lessons?
I'm sorry. Is it y equals 12x? Yeah, it is.
Does this pattern work? Can I take the number here, multiply by 12, and get the range?
Yeah.
Yeah. Yeah. The pattern from going from lessons to money is take this number and multiply by 12. So this number multiplied by 12 is 12 times, say, x, if you call it lessons. If you said this was L for lessons, you could say 12L. Okay? And so on. So here's our function. Y equals 12x. Identify the independent and dependent variables. What's the independent variable? What does the independent variable go with? X and domain. So what are the independent variables? What's the independent variable here? Number of lessons. Independent variable is the lessons. What's the dependent variable? What depends on the number of lessons? The money that we spent. So the dependent variable is the money spent. Okay. And if you know the independent variable, what does independent variable get matched up with? What's another word we use with independent variable? Domain. So if you know the independent variable, that means you know the domain. So then what are all of the possible values in the domain? The domain.
That's smart.
And then the range, therefore, is the dependent variable. So those numbers are the ranges.